Hello viewers, this is Prof 1 Tutorials. You are all welcome back to this channel. Today we are going to look at another aspect of Mensuration II. Mensuration II. Today we are going to look at the square pyramid. The square pyramid. So viewers, join me and let's get started. A square pyramid is a solid figure which has its base to be in the form of a square and it has an apex. So that is basically about a square pyramid. So we are going to look at a sketch of a square pyramid. All right. So this is a sketch of a square pyramid. So we can see that the base is in the form of a square. Then the tip here, we call it the vertex or an apex. So every pyramid has a vertex or an apex. Then the base, from the name a square pyramid, meaning that the base is in the form of a square. So let's name the base to be P, Q, R, S. Because the base is in the form of a square, this means that PQ is equal to QR, it is still equal to RS, and it is still equal to SP. So distance PQ is equal to QR, and it is equal to RS, and then they are still equal to SP. Because the base is in the form of a square. The base is in the form of a square. Now we are going to look at how we can find the volume of a square pyramid. How we can find the volume of a square pyramid. So in finding the volume of a square pyramid, the volume of any pyramid must always start from 1/3. You must start with 1/3 if and only if the solid figure is a pyramid, multiplying the area of the base. So multiplying area of its base times the height of the pyramid, multiplying the height of the pyramid. So from here we are going to look at some of the parts of this square pyramid. Now let me name this dot as O. Then I will name the apex as B. So we have BO. So viewers, BO, that is the short dashes, is describing the height of the pyramid. So BO is the height of the pyramid. All right. Then we have BP is equal to BQ. It is still equal to BS. It is still equal to BR. They are all equal, and we call them the slant edge. The slant edge. So BQ is equal to BP. It is still equal to BR, and it is still equal to BS. And they are all equal. They are all equal. And we call them the slant edge. The slant edge. Again, we have faces of the square pyramid. We have 4 triangular faces. So the first face is BSP. BSP. It is equal to another face BPQ. BPQ. It is still equal to PRQ. That's another triangular face over there. So BRQ. And the last one is BSR. BSR. And we call these triangles the slant faces. The slant faces. Now, we can get the height of this triangle. So let me use another short dashes to represent it. Okay. Now, the short dashes I have introduced here, we call it the slant height. The slant height. So let me name here M. So this means that BM is a slant height. BM is a slant height. And we can use this slant height to find the height of the main pyramid when sometimes a question is given. So I can join this with short dashes, and if you look at the short dashes I have indicated, it is forming a right angled triangle because this side can be 90 degrees, and using this right angled triangle you can find the height of the pyramid. Now we are going to look at the total surface area of a square pyramid. So let's look at how we are going to find it. In finding in finding the total surface area of this square pyramid, I am going to use the net of the pyramid to explain much more better. So this is how the net looks like. So we have the base, which is a square. Then every square pyramid has 4 triangles. So we have the first triangle to be this way. We have another triangle here. Then we have another triangle here. Then we have the last one here. All right. So this is the net of a square pyramid. So if you want to find the total surface area, so the total surface area of the square pyramid, it is given by the area of this square. So area of the square plus the area of the four triangles. As simple as that. So multiplying area of the triangles. Or let me make it of the triangle. Okay. So the triangles are four. 1, 2, 3, 4. So 4 times area of the triangle. And this is how we find total surface area of the square pyramid. So viewers, join me and let's look at an example and how we are going to solve them. So viewers, stay tuned. Let's move on. Example. A pyramid which stands on a square base. A, B, C, D with vertex O. OA is equal to OB is equal to OC is equal to OD is equal to AB is equal to 5 centimeters. Calculate A, the height of the pyramid. B, the volume of the pyramid. C, the angle between OAB and the base. D, the total surface area of the pyramid. Then E, the angle between faces OAB and OCD. All right. So this will be the example, and we are going to look at how we can give out the solution. So viewers, let's get started. When a question is given under mensuration 2, it is very advisable you give the sketch of the diagram. It will help you to know how the solution will be. So it's a pyramid, and the question said it stands on a square base. This means that it's a square pyramid because the base is in the form of a square. So let's give a sketch here. All right, so the base is A, B, C, D. So this is the base. Then the question said the vectors is O. So vector O or vertex O. The question said OA is equal to OB is equal to OC is equal to OD. So we have OA equal to OB equal to OC equal to OD. And from the previous explanation, I said they are called the slant edge. They are all slant edges. And it is still equal to AB. So this is my AB. So this side is 5 centimeters. And because the base is in the form of a square, it means each side will be 5 centimeters. So meaning DA, AB, BC, CD, they are all 5 centimeters. And OB is equal to OD is equal to OA. It is still equal to OC. They are all 5 centimeters. So now let's look at how we can find the short dashes here. The short dashes here. Now let me name this point as Q. That would be my point Q. So the height is going to be OQ. So we are going to look at how we can find the height OQ. Before we can get this height, we need to get the distance here. This distance. Now, Q is here, but we don't know what is here. I am going to name it as M. M. So point M. Point M. But this whole side is 5 centimeters. If I'm able to get QM, it can help me to get the height. But we can see that QM is half of DA. QM is dividing DA into 2 equal parts. So QM is half of the 5 centimeters, which is going to be 2.5 centimeters. And again, we need to also get the distance here. All right. Now we need to also get OM. Now OM from here is the height of triangle OAB. If we are able to get OM, then we can use Pythagoras theorem to find OQ, which will be the height of the pyramid. So let's look at how we are going to do it. All right. So from triangle OAB, let me give a sketch of it. So we have OAB. Then this is the height of that triangle. And this side is M. So triangle OAB. That is what I have drawn here. And we want the short dashes here, which is OM. Now from here, OA is 5 centimeters. OB is 5 centimeters. And AB is also 5 centimeters. Now we are looking for the height here, H. That's the short dashes, H. Now before I can get H, I need to get AM or MB. Now AM is going to be the half of AB. So this side is 2.5. And MB will also be 2.5 centimeters. So you see that 2.5 plus 2.5, it will give us the 5 centimeters. So I am going to take one of the right angled triangle. So I'm going to stick to this. Because OMB is now a right angled triangle, then I can use the Pythagoras theorem to find for the height of that triangle. In using Pythagoras theorem, I am going to first of all square the hypotenuse. So I have 5 squared is equal to H square root plus 2.5 square root. So from here, 5 square root, I have 25, which is equal to a squared will be repeated plus 2.5 squared, we are going to get 6.25. Now from here, we need to group like terms. So I have 25 from here. Then I'll find the additive inverse of 6.25. It will give me negative 6.25, which is now equal to h squared. Now from here, 25 minus 6.25, I'll be getting 18.75, which is equal to h squared. So let me continue from here. Now from here, I am going to take the square root on both sides. So root of this and root of this. The squared here will cancel the radical sign. So I am going to get the height. So I have the height to be equal to. Now when we take square root of 18.75, it will give us 5 root 3 over 2 centimeters. And this will be the height of that triangle. Since we have the height of the triangle, then it will help us to get the height of the pyramid. So now I am going to resketch the square pyramid again so that we can look at where we can put the 5 root 3 over 2. So we are going to look at the sketch. So let me put the sketch here. Okay, so initially this was the sketch. Okay, then we have the short dashes to be here, and then another short dashes here. All right, now we have A, B, C, D. Okay, then this side was 5 centimeters, another 5 centimeters. We have vectors O, we have here to be Q, and we had here to be M. This side was also 5 centimeters, and this side was also 5 centimeters. And now, because QM is half of DA, then it means QM will also be 2.5. So let me put the 2.5 here. Then now we have OM. OM. So here, therefore, OM is 5 root 3 over 2 centimeters. And this OM will be the height of this triangle. Now, viewers, before we can get the height of this pyramid, we have to figure out the short dashes. And from here, the short dashes looks like a right angle triangle, or the short dashes is a right angle triangle. So we have OQ, we have OM, we have QM, which will be like this. So we have OQM, and we have here to be 90 degrees. So now this is the height. So let me make it big H. Then we have QM to be 2.5 centimeters. And we have OM, which is now 5 root 3 over 2 centimeters. Since it's a right angle triangle, we can still use the Pythagoras theorem to find for the height of the pyramid. So in using Pythagoras theorem, we are still going to square the hypotenuse again. So we have 5 root 3 over 2 squared, which is equal to the square of the other two sides. So we have h squared plus 2.5 squared. Now from here, 5 root 3 over 2 squared, 5 root 3 over 2 squared, we have 18.75, which is equal to h squared plus 2.5 squared, we have 6.25. So here we are going to group like terms. So we have 18.75. Then I will take the additive inverse of 6.25. I have minus 6.25, which is equal to h squared. From here, I am going to take the difference. So we have 18.75 minus 6.25. We are going to get 12.5, which is equal to h squared. So when you get here, what do you think we are going to do? We are going to take the square root on both sides. So we have root of h squared and then root of 12.5. This will cancel this. We have h. And root of 12.5, we are going to get 5 root 2 all over 2 centimeters. And this will be the height of the pyramid. This will be the height of the pyramid. So let me make a conclusion. Therefore, the height of the pyramid is 5 root 2 over 2 centimeters. And this answers the first part. So now let's look at the second part of the question, which is the volume of the pyramid. So B, volume of the pyramid. Now, in finding the volume of the pyramid, since the pyramid is a square pyramid, then it is 1 over 3 multiplying area of its base. Area of its base times the height of the pyramid. So we have 1 over 3 times. Now we all know that the base is in the form of a square and each side is 5 centimeters. So area of a square is L times the big H. So we have 1 over 3 times L is 5 times another 5 times the height, which is 5 root 2 over 2. So we are going to evaluate them. So we have 1 over 3 here. I am going to repeat it again. Times 5 times 5, we have 25 times 5 root 2 over 2. 5 root 2 over 2. And when we multiply 1 over 3 by 25 by 5 root 2 over 2, we are going to get 29.4628 centimeters cube. Centimeters cube because you are looking for the volume of the pyramid. So this will be our final answer. C. the angle between the face OAB and the base. I am still going to resketch it again so that we can use it to understand this question very well. So this is our square pyramid. So we have vectors O, we have side A, B, C, and D. This side is 5 centimeters, another 5 centimeters, another 5 centimeters, and 5 centimeters. Now we have face OAB, which looks like this, and the base also looks like this. So the angle formed, so the angle be formed here. This is where the angle be formed. Now we know, so the angle be forming from the short dashes. Okay. So this is how the short dashes looks like. So this is the angle we are looking for. Because the base looks like this, and then the face also looks like this. So we are going to take it from this and this. So the angle, I am going to use theta to represent it. Now we have Q here, we have M here. So we have Q, we have M, we have O. Now this side is 2.5. Then the height, OM, we had 5 root 3 over 2 centimeters, and with the height we had 5 root 2 over 2 centimeters, and here is 2.5 centimeters. So from here we can use any of the trigonometric ratios, either sine, cos, or tan, because all the sides have been given. So let me take tan theta, which is equal to opposite over the adjacent. So we have 5 root 2 over 2 all over the adjacent is 2.5. So viewers, when we divide 5 root 2 over 2 divided by 2.5, we are going to get root 2. So tan theta is equal to, so when you divide these two, we are going to have root 2. Then we can now get the angle. So we are going to maintain theta. Then it is equal to tan inverse of root 2. So tan inverse of root 2, we have 54.7356. So we have theta to be equal to 54.7356 degrees. So now we can conclude. So therefore, the angle between face OAB and the base is 54.7356 degrees. So from here to the nearest degree, we can have 55 degrees. Into brackets, the nearest degree. the nearest degree. Now we are going to look at the total surface area. D, the total surface area of the pyramid. So from the previous explanation, I said that with the total surface area is going to be area of the base, which is a square, plus area of the four triangles. So area of the square plus 4 multiplying area of the triangle. All right. So I am going to resketch it again. All right. So we have the vectors O, A, B, C, D, 5 centimeters, another 5 centimeters, another 5 centimeters, and here is also 5 centimeters. So viewers, the base is a square, which is L times L, plus 4 multiplying area of the triangle, which is half times the base of the triangle multiplying the height of the triangle. Now I am going to take one of the triangles. So the triangle here. Okay. So from this triangle, the base is 5, then the height. From our previous calculation, we had the height to be 5 root 3 over 2. So this is 5 root 3 over 2 centimeters. So we have 5 times 5, because each length is 5, plus 4 multiplying half times the base of the triangle is 5 times the height. From here we have 5 root 3 over 2. So from here, these two can go to 4 2 times. Then this same 2 can also cancel what we have here. So from here, 5 times 5, we have 25 plus, then 5 multiplying 5 root 3, we have 25 root 3. So from here we can add 25 and the 25 root 3. So when you put them together, we are going to get 68.3013. So we have 68.3013 centimeters squared, because we are looking for the total surface area. Now let's look at the final question. Our final question. Now our final question is the angle between face OAB and OCD. Now viewers, let me extend this a little bit like this. Then we can also get the height of this triangle this way. All right. So here we have short dashes, another short dashes. So we have here to be M, we have here to be Q, and we have here to be P. So we have OP, we have OM, we have OQ. So I am going to use this sketch to explain it better. So we have PQM. So P here, Q here, M here, from the base of the short dashes. Then we have the top to be O. So from here, OM is equal to OP. They are all height of the triangle. So here will be 5 root 3 over 2 centimeters. This side will also be 5 root 3 over 2 centimeters. And DA is equal to PM. So the whole of this distance is 5 centimeters. Because moving from P to M is the same as moving from D to A. In that case, PQ is going to be 2.5 centimeters and QM will also be 2.5 centimeters. Now we are looking for this whole angle. So theta plus another theta. So I am using this angle as theta, another angle here to be theta. So if I am able to get this angle, it will be the same as the angle here. Now the angle faces the 2.5, which is the opposite, and this side is the hypotenuse. So opposite and hypotenuse, we are going to use sine. So with this particular angle, we are going to use sine to find the angle. So from triangle OQM, I have sine theta is equal to opposite, which is 2.5 over the hypotenuse, which is 5 root 3 over 2. So 2.5 divided by 5 root 3 over 2. We are going to get root 3 over root 3. So 2.5 divided by 5 root 3 over 2. It will give us root 3 over 3, for which we still have sine. So I'll maintain the theta, then I'll have sine inverse of root 3 over 3. So sine inverse of root 3 over 3, we are going to get 35.2644. 35.2644 degrees. But this is not the final answer because we are looking for the whole angle. So therefore, the angle between faces OAB and OCD is going to be twice of this. So 2 multiplying 35.2644 degrees. 8. So 70.5288 degrees. So if you are to correct to the nearest degree, we have 71 degrees. So to the nearest degree, So fellow viewers, this is where we will end for today. In our next video, we are going to continue with the pyramid. So viewers, continue watching. Don't forget to like, don't forget to share, don't forget to comment. You can still subscribe if you haven't subscribed yet. Stay tuned. Bye bye.